Half inch doesn't sound like much until it's the difference between a perfect part and a broken tool. Welcome back to Chuck's Corner, where I share real stories from CNC manufacturing. This one takes me back to a job where we were machining a deep pocket in a large aluminum component. We had a long reach end mill set up specifically for the job. Tool length, stick out and holder combination had all been worked out during the prove out, and the first parts were coming off exactly as expected. Then we had to replace the cutter. The replacement tool itself was identical, same diameter, same style, same manufacturer. So the machinist rebuilt the tool assembly, touched it off and carried on. A few minutes into the next part, we started hearing something we didn't like. Not a crash, not a big bang, just that little change in the sound of the cut that makes you stop and pay attention. We checked the tool, the cutter looked fine, the holder looked fine, the offsets looked reasonable, so we ran the tool again, and that's where we spotted it. The replacement assembly had been built with a different amount of stick out, not much, about ½ an inch. But on a deep pocket, ½ an inch changes everything. The tool was now behaving completely differently. The extra stick out increased the amount of deflection, changed the cutting conditions and put the cutter much closer to the limits we'd established during the original prove out. The interesting part, if you had just looked at the cutter and holder sitting on the bench, you probably wouldn't have noticed anything wrong. They looked like the same tool, but they weren't the same assembly. We rebuilt the tool to the original configuration, reset the tool length and ran the part again. The difference was immediate. The cut stabilised, the finish came back and we were back to the process we'd already proven. And that's the lesson. When you're replacing a cutting tool, don't just match the cutter, match the assembly, the cutter diameter, the holder extension, the stick out, overall length. All of these things can affect how that tool behaves in the machine. And this is one reason I like having the tooling information documented rather than relying on someone's memory or a handwritten setup sheet. With MachiningCloud, you can document your tool assemblies and associate tooling with jobs. So the next person has a much better chance of rebuilding the setup the way it was actually proven. Because sometimes the biggest machining problems don't come from using the wrong tool. They come from using the right tool in the wrong configuration. Have you ever replaced a cutter and assumed the new assembly was identical, only to find out later that something small had changed? Drop your story in the comments. I'd love to hear what you've run into on the shop floor. Thanks for stopping by Chuck's Corner. Stay safe, stay sharp and own the process.